Vanakkam, Namaste, Namaskar. Welcome back to Jal Prayag. I'm going to continue today with the wind triangle concept, which I've done as part one. So I'm going to talk about a couple of problems today. So let us get into solving some problems of wind triangle. Before I just dive into the questions, I'll do a quick recap. And I suggest if anyone who is coming and watching this video for the first time, please have a look on the part one, which was purely the concepts. It'll be much easier for you to understand and approach the problems if you have a look at part one. We had discussed the instrument which we use on board is called anemometer, or commonly known as the wind vane. And this instrument measures only the apparent wind direction and speed if your vessel is moving. If your vessel is stationary, the readings what you get from anemometer is same as true. Quick word of caution, all logbook entries and wind reports or weather analysis reports, they should be given as true. So how do you convert if I'm given an apparent reading into true and then put it in a logbook? If you recollect, I had told you that there are two ways of solving this problem. The first one is what you do in a sheet of paper, which you're going to do in your exams also. That is what you're supposed to do. And then I showed you a couple of pencil and a rope principle. I'm going to just recap on this that concept because in a day-to-day life on board, you can still use this rope and pencil concept to quickly come to a approximation. You will not be accurate, but approximation you can still get. Rather than writing false readings on the logbook, you can still use it. I'm going to show you still a bit of that. This was a similar diagram which I had shown you, where I had considered the green color part of this triangle as the pencil number 1, and the orange color circle as pencil number 2, and I had tied a rope, a single piece of rope on the green color pencil, and then when I stretch pencil number 2, I could form a triangle. And this could be two parts of the triangle also, and each of them become vector. So I have three vectors on this triangle. Your AT, which was the pencil number 1, is the vessel's course and speed with the direction and as well as distance. Then you will see the maroon color component of the rope is called the true wind part of it, and the blue is your apparent wind part of it. Now, before you start solving any problem, you need to take a scale. So you can take a scale of 1 centimeter is equal to 1 knot or 1 nautical mile, depending on what you are doing. So it's 1 centimeter is equal to 1 nautical mile is a good scale. Now, for your calculation on your sheet for your exam, I need to draw grids. Grid for measurement of the directions is very important. I'm going to show you the grids, but the big word of caution is the grid should not be drawn at all the three places. It should be drawn only at two places, which are your alpha and tango. So I'm going to show you grid number 1, alpha. Grid number 2 is the tango. Never draw grid on Oscar. Now, what is the purpose of the grid? Please remember, wind direction is always mentioned as the direction from where it is coming. Okay, it's coming from direction. So that means it is as if you are standing on the grid which I've drawn at alpha, and you will see the blue color vector coming towards you, which is your apparent wind direction. If you stand on the second grid, which is at tango, you will see the maroon color wind coming from the true direction. So this is what is the concept of the grids. I had shown you the pencil concept, the same picture I had shown you. All I had told you was, I'm going to incorporate the grid here now. So your ship's direction and length depends on what is given to you in the question. and I can tie a rope from alpha to tango. And when I use the pencil number 2 to stretch it, I get two components. I can move the pencil in various directions, and that is going to give me different vectors of the true wind. Okay, so what I'm going to do now is, if I get a choice where I can change the length of the ropes also, I can use it to measure different lengths of true wind and apparent wind also. I'm going to use again the same old sheet and same old example which I had earlier shown you in the previous module, where I had given you a couple of examples. I'm going to just take three examples, the easy ones, and just compare it with the rope principle. Now, this question had the ship moving northerly at 10 knots, and I was having a wind coming from northerly direction also 10 knots. And we already saw the anemometer is going to give me speed of 20 knots. So I'm going to just quickly show you on that pencil and the rope concept. Let us say I had this pencil number 1 showing me ship 10 knots as 10 centimeters. And then what is given to me is northerly wind 10 knots. I mark alpha and tango. True wind is OT. So I'm going to stretch the pencil like this and give this rope 10 centimeters, which is showing me the true wind. So now if I want to find out what will be the anemometer reading, all I have to do is join O and A, and you will see it is 10 plus 10, which is 20 centimeters. So this was the simplest concept I had earlier mentioned. I can do it with the rope also. Similarly, I have one more example. Let us look at this. Ship moving same northerly 10 knots. Wind speed southerly true 20 knots. So what is the anemometer going to show you? So the ship is 10 centimeters. The true wind is 20 knots. So that means 20 centimeters. I'm going to take this 20 centimeter length. What will be the apparent? Apparent is just join O and A. You will see that will be 10 centimeters. So this is what the rope principle also shows you. You can solve it on the books also, on the sheet also similarly. Now let me take one last example, which is ship doing 10 knots northerly and wind speed coming from southerly direction also 10 knots. So please see here, alpha tango, ship speed is 10 centimeters. True wind is OT is again 10 centimeters. So O to T has to be going in the same direction as the vessel because the wind is southerly. If that is 10 centimeters, what is OA? O and A are in the same spot. So you should get answer as 0. And this is what your anemometer is also going to show you. So these three examples were just to compare the rope concept and the real principle. But let us go to purely the sheet concept, which all of you are expected to do in the exam. Let us take one question. A couple of questions are from the book, and one question is one of the MMD exam questions. So I can solve all the three for you for having a variety of different questions. So all the three questions are slightly different. Now he has given me data here, vessel sailing with some course and speed. True wind is from southeasterly 11 knots. And he says in the question, find the anemometer reading on the vessel. So let us quickly write down first of all what is there and what is not there. It's a good way of starting question because you should know what you have and then what you're supposed to find. So that makes a little bit more systematic and presentable approach to solve a problem. I'm writing AT, which is your ship's component as 26714 knots. OT, which is your southeasterly. So the wind is coming from 135 degrees to 11 knots. I'm supposed to find OA. Now, how do you normally start? You'll have to start with what is given to you. And whenever ship speed and the course is given, please start with that. Why? Because you'll be able to draw both the grids at alpha and tango. Now, before you put this in your paper with alpha and tango, a small word of caution, you should decide where should I draw this AT on the paper. If you draw on the wrong side of the paper, that means you may not have any place to draw your rest of the wind components. So you should choose this wisely. A small bit of thought. I'm going to use the same radar plotting sheet because for me it's easy to measure the scale I've chosen. I've chosen the scale, one of the scales here. It's very easy for me to do it, so I've done. Now I should start with alpha. Please remember, I'm going back. Your ship is doing approximately westerly course, and the wind, true part of it is coming from southeasterly direction. So that means I need to have a place on the southerly direction to draw the wind, the true wind. And you will see most probably the apparent wind also will be coming from the southerly direction. So let us quickly have a look here to choose where should I put this alpha tango. So I'm trying to choose it on the northern part of the sheet. So I take a grid. I call this alpha. Please keep it exactly north, south, and east, west. Otherwise, your answers will be wrong. I'm going to measure 267 clockwise and draw my ship. You will be drawing a small pencil sized line. So this is only for depiction. So please don't bother. You draw a pencil line. Measure this green color alpha tango as 14 centimeters. And please mark the direction. Mark tango, and that is a second grid. Both the grids should be parallel and similar. Please don't do the mistake here. You have to be careful. Okay. Now he has given me the true wind already. It says wind is coming from 135 degrees. So wind is coming from southeasterly. So my full diagram is going to be on the southern part of this vessel. So that is why I chose a little bit north on the paper. Okay. So I'm going to measure 135. Put it. Please look at the arrow. Wind is coming from 135 and this length is 11 centimeters, which I measured with the scale. So this point becomes my O. Please join O and A, and this becomes your direction of apparent wind coming from. So where will you measure? You will measure only at alpha. So I'm going to measure this at alpha. So when I measured it, I found this was the answer. It was 215 degrees true and 10.7 knots. So these are the three values. Two values were given to me. I found out the third value. So this is how a problem is solved. I'll take you to two more problems. This time I'm going to change the data. I'm going to give you a new question where he has given you the vessel course and speed, but this time he gives you anemometer reading of 0, 3, 6, and 15. So find the true wind to be logged. Again, let us just quickly jot down what we have and what we need to find. Alpha tango given to me, OT not given to me, OA is given to me. Again, before going to the sheet, should realize my course is, vessel's course is approximately easterly, and the wind is coming from northerly direction, northeasterly, which has got a northerly component. So I will choose the sheet in such a way that I can keep empty space on the northern direction of my vessel. So I'm going to choose it slightly on the south side of the sheet. I'm going to take the first grid as alpha. Please draw 117, 16 centimeters. Mark the tango and draw the second grid. He has given me apparent wind data as 036. So wind is coming from 036. I will go to alpha. I will measure 036 and draw a line. This line is supposed to be 15 centimeters, and I call that as Oscar. Now all I'm going to do is join OT. I need to measure this direction at tango. Please measure it. you will get an answer 3, 4, 5 degrees into 20 knots. Please remember, whenever you draw, depending on your accuracy, depending on your instruments, depending on your paper, how good you have drawn the grid, you might get some errors in the answer. Couple of 1 or 2 degrees from 3, 4, 5 is acceptable. Couple of decimals at 20 knots is also acceptable. So don't bother about that. It depends on a few errors which can come, human error and your instrument error also. So please don't bother about it. Go ahead and do it as correct as possible. Whatever you get, you have to write it in the exam. You don't have any means of checking whether your answer is right or wrong. And this is maybe one place where you can imagine the rope concept and get an approximate answer to see whether I have done it right or wrong. So that is why rope concept, I am promoting the rope concept, because it's very logical and you can imagine the rope. You can imagine the rope and the two pencils also, and you can still try to solve a problem and get an approximate answer. Let me solve the last question. Again, it's quite different. You can see vessel is given a course and speed. It says found the anemometer reading as 11 knots. That means the reader on the scale was 11 knots. And then he talks about funnel smoke was blowing towards 2 points forward of the starboard beam. Find the true wind to be logged. Now let us quickly jot down what we have. Alpha Tango is given to me. OT I have to find for logging. Now please look at the next part. Your next component of apparent is given in terms of funnel smoke. Few points you have to remember. Number one, you need to know your relative boxing. If you have any doubt, please go to my earlier video, which is relative boxing. There's a small video regarding relative boxing. It says the smoke was blowing towards 2 points forward of the starboard beam and the speed was 11 knots. Let us quickly figure this out, how to solve this problem, how to decipher this OA. Let us quickly look at this. For this, I'm going to draw my real ship's true course. He has given me 135 degrees. He's talking about beam, so I'm going to draw a beam line, which is 90 degrees port and starboard. So your starboard beam will measure 225 degree true, and your port beam will measure 045. I need both of them because let me show you why. Now, he says the funnel smoke was blowing towards 2 points forward. So I'm going to put 2 points forward of starboard beam, which is 22.5 degrees. If you remember, 1 point is 11 and a quarter. Now I'm going to draw this line from the center. And this funnel smoke is going towards 202.5. Okay. Now, how to solve this problem? Let us see. And then I'll show you the concept behind it in the next slide also before we actually solve the problem. Now, let us say a vessel experience a funnel smoke and the smoke is going out like this. Okay, the smoke is going out like this, which very clearly means that the wind was coming from here. And this wind, please remember, is directed at apparent wind. So that you should be careful about. So what it means is, in this question, the funnel smoke was going 202.5. So that means the wind was coming exactly from the opposite direction. So 2 points abaft of the port beam was the apparent wind direction. So this is 2 points abaft of the port beam. And that angle, what you get is 0 to 2.5. Okay. So I got the answer for solving my problem now. Apparent wind is coming from 0 to 2.5 and the speed was given to me as 11 knots. If by chance this question had mentioned instead of funnel smoke, let us say a flag, you will see the flag also will be fluttering in the exact opposite direction of the wind. And it is apparent wind, please remember. Let me show you in the next slide. I hope this is clear. This is a slight tricky part of this wind triangle. Otherwise, wind triangle is very easy. Let me show you a couple of other things also. Let us solve this question and I'll come back to the concept. Again, please look at the question. I was sailing somewhere southeasterly direction with the vessel, and the apparent wind is coming from northeasterly direction. So I'll try to keep my ship on the southern part of my sheet so that I can keep some empty space on the northern part. So I'm taking the first grid as alpha, draw 135. It is only 6 knots. The ship speed was very less. I got tango, so 86 centimeters. I got the second grid also. Now we already found out the apparent was 022.5. In practical drawing 022.5, you can as well take as 023. It's okay because half a degree finding from a protractor is very, very difficult for you. So you can take it as 023. Small errors will be there, but still acceptable. So I'm going to draw 022.5 and 11 centimeters. This is what I'm going to draw. 022.5 and 11 centimeters. And I get Oscar. I connect Oscar and Tango. And I measure this. I get an answer of 360 or 000 and 14.6 knots. As I told you, couple of degrees on the direction is acceptable, and a couple of decimal values on the speed is also acceptable. So please don't bother too much about it. Draw the grid properly. I think you'll get all the answers, mostly very close to the actual answer. So this question was slightly different. I hope it was easy to understand. The catch was with this apparent. Let me, before I wind up, just quickly give you what kind of indirect wind directions they can give you in a question. Okay, they will not give you directly, they will give indirectly. And one of them we saw was this last question. So there can be more. Let us quickly see. One was this funnel smoke, which we just saw. Second one could be a flag, which is fluttering. Third one could be, they could say that somebody is holding a handkerchief and it is flying in this direction. Or they could say that somebody threw bits and pieces of paper and it started flying in particular direction. Please remember, all of them are indicating only apparent wind. And you should realize that the apparent wind is coming exactly from the other direction from what I have shown you here as the flag fluttering or the smoke going, the papers flying, or the handkerchief. So this is your apparent wind direction. This happens because as soon as you release the smoke or the papers or the flag, what you have, they're all related to the motion of the ship. So they get the motion component from the ship also. That is why they're all apparent, they are not true. So please use this as OA in all your questions. Now there is something else also which comes indirectly. The sea wave direction can be given. Visual sea conditions can be given. They can give you the direction of the white horses which are in the sea. They also can be given. Let us look at some pictures. You can see this. The white horses and the spray are going in this direction. Wave direction is also like this. Please look at here. This is also the sea sprays and the white horses. Here also, sea spray and the white horses. They indicate only true direction, which means the wind is coming from here, from here. Now, these indirect readings, they are independent of the vessel movement. Why? Because it is on the water. So please consider this only as the true wind. Now, there's one more indirect way of giving you some scale in the question. Many times they use the Beaufort wind scale. Scales are given usually only for true wind only. Okay. They come with ranges. I'll show you in the next slide. Questions can ask you to use the highest speed in that particular category. Category means what is the Beaufort number. So please look at this Beaufort wind scale for a sample. Please remember this is a sample. I have Beaufort numbers 0, 1, 2, 3. This is what will be given to you in the question. And they have a name for them. It can be your calm, light, then breeze, strong breeze, near gale. And then he gives you the knots. So this is how it is given. You can see in the knots, they have given you a range. Let us take Beaufort 4. So it is 11 to 16. So that means there's a range. They can specify, please use the highest range. So you will take 16 knots as your wind speed and then solve the problem. So this is how you go about solving your wind triangle problems. That's the end of my second part of the wind triangle. If you want me to solve additional questions, if you have any specific questions, you can always put it in the comment section. I can quickly make one PPT for solution of that kind of problem. But I feel that these three problems, what we have solved, is good enough because all the three were different types of question. Each data was slightly different. But yes, as I said, you are free to comment in case you have any particular question. You can always specify in the comment box, and I can try to make one short video for that particular question and solve for you. So I'll leave you today. I might change over to chart work concepts because it's been quite a while since I did the first video, and after that, this is the 13th video. I'm sorry, the second video was the chart work. This is the 13th video. I might get back to it, and then let us see what is the trend or the feedback from you so that I can change. Anyway, keep watching Jal Prayag. Namaste, Wanakam, Namaskar. I'll catch you soon.